Hey everybody, going to go over our last review of the year. All right, your quiz will be tomorrow. Okay, obviously much shorter than this. All right, but problem similar to this, but just on a much smaller scale. All right, so the first section here, we are simplifying. We're evaluating logs. Okay, now to do this, you always put the base to what power equals whatever comes after it. So if there is no base, that means we're dealing with base 10. So 10 to what power gives me 10? All right. And the answer there is just 1. All right. Here, it's what base do I have here? It's 6. To what power gives me 1 over 36? Okay. Because what we're doing here is if we set these equal to x, because that's what we're trying to figure out what it equals to, all right, we're changing this to an exponential, all right, which is the base to that equals that left, right, left, left, right, left. That's what we're doing here. All right, so 6 to what power equals 1 over 36? Well, it's just 36, it'd be 2, but since it's 1 over 36, all right, it's going to be negative 2 is our answer, all right, because 6 to the negative second is 1 over 6 squared, which is 36. All right, so whenever you see 1 over something like that, it's going to end up being a negative exponent. All right, natural log. What's the base of a natural log? It's e. So e to what power gives me e cubed? That's just 3. All right, 2 is the base. To what power gives me 32? All right, 2 to what power is 32? Well, I can just go through 2 to the cube, just 8. 2 to the fourth is 16. 2 to the fifth is 32. So the answer is 5. All right. 5 to what power gives me 1? All right, well, that answer is 0. Log base of anything of 1 is always 0. All right, natural log of e, you should know that right away, is 1. All right, natural log of e is 1. And if you don't know that, what's the base of a natural log? It's e to what power equals e. It would be the first, so it's just 1. But you should recognize the natural log of e is equal to 1. All right, log base b of b cubed, what does that equal to? Well, b, because it's the base, to what power equals b cubed? Well, 3. All right. All right, this one's a little trickier. We have 8 to what power equals 32? Well, obviously, it's not an exact, it's not like a whole number, right? Because 8 squared is 64, right? But what you can do is we can make these the same base, all right? I can rewrite this as 2 cubed, 8, right, to the x, equals 32, which is talked about as 2 to the fifth. So basically, this is 2 to the 3x, that's a 3, sorry, equals 2 to the fifth. So you set the exponents equal to each other, and you get 3x equals 5, x equals 5 thirds. That is your answer. All right, 9. There's no base, so it's 10 to what power equals the cube root of 100, which is really 100 to the 1/3, right? I could make 100 10 squared, which means 10 to the x equals 2 times a third is 2/3, 10 to the 2/3, and the answer is 2/3. All right, and the last one here, e to the what power equals 1 over e squared. All right, so this is similar to number 2. We're going to have a negative answer, and the answer is negative 2. All right, so hopefully you guys understand that pretty well. All right, now for a problem like this, all right, 11, 12, and 13, where you're given log base a of b is 4, and log base a of c is negative 3. All right, find these things. Okay, so what you want to do is use your properties of logs to see if you can rewrite these in a way, then substitute in these values. All right, so for example, the only property we can use right here is move that 4 out front. So 4 log base a of b, which means 4 times, what is log base a of b? We can substitute that 4 in to that, and it's 4 times 4, which is 16. All right. Log base a of the square root of c is really c to the 1/2. So I can rewrite this, bring the 1/2 out front. 1/2 log base a of, just c, sorry. And log base a of c is just -3. So 1/2 times -3. So the answer is -3 halves. Okay. This one we can expand a little bit more. Okay. So anything up top, it says positive, anything at the bottom gets a negative. Exponents go up front. So it's 2 log base a of a plus 3 log base a of b minus 5 log base a of c. Okay, now this right here, log base a of a, anytime you have the same base there, and this is just 1. So the answer is 2 plus 3 times what's log base a of b? It is 4 minus 5 times log base a of c, which is -3. So we get 2 plus 12. That's a positive, plus 15. So 14 plus 15, the answer is 29. All right. So 14 and 15 are very similar. All right, now we're just using decimals, all right, and real numbers, not just like variables. All right, so how can I rewrite 36 using log 2 and log 3? All right, so what is 36? What is 36? How can I do that in terms of 2 and 3? So that's what we got to think of. All right, so 36 is what? 9 times 4? Well, isn't 9 3 squared and 4 2 squared? So if I rewrote this as the log, instead of 36, I'm going to rewrite it as 3 squared times 2 squared, which is the same thing, right? But now these are properties of log. The 2 goes out in front. 2 log of 3 plus 2 log 2. And now I substitute those values in. 2 times 0.301 plus 2 times, sorry, I got a little dyslexic there. Log 3 is 0.477, sorry. And log 2 is 0.301. I want to change the answer because it's 2 times that. So 0.477 times 2 is, what's 77 for? That's 2, 4, 5, 8.94 plus 0.602, which gives me 1.556 is my answer. All right, so this one, all right, could be something similar, right? Division, I know it's subtraction, right? So log 8 minus log 9. How can I rewrite 8 and 9 in terms of 2's and 3's? Well, I can rewrite 8 as 2 cubed and 9 as 3 squared. So it can be 3 log 2 minus 2 log 3. So 3 times 0.301 minus 2 times 0.477, which is 0.903 minus 0.954, I believe, which then is what? Negative 0.51? Oh, negative, hold on, no. Negative 0.051. All right. All right, so for these problems, you just rewrite in terms of what you have using the properties of logs. All right. Solving each equation, give the exact answer, then round it to the nearest thousandth. Okay, so All right. So for these types, this is an exponential. How do I know it's exponential? Because it's got x in the exponent. It's either an exponential like this or you're going to have a log in the problem. Okay. If you have an exponential, you want to get the exponential by itself first. All right. So I'm going to get 15 over 4 equals 3.2 to the x. Okay. All right. So now once you've got the exponential isolated like this, then you're just going to add a log to both sides. Okay. So I get log of 15 over 4, which is, I'm going to change it as 3.75. You can keep it as 15 over 4, doesn't matter. Equals, now when I do this, when you add the log to both sides, the reason you do that because you want to move the exponent out front. So it's x log of 3.2. Then to solve for x, you just divide by log of 3.2. And this right here is your exact answer. Log of 3.75 over log of 3.2. Now, let me show you if I get rounded to the nearest thousandth. All right, so see now here I have a calculator pulled up. Okay, so to put log of 3.75 divided by log of 3.2. So in order to round it to the nearest thousandth, you need a thousandth or the hundredth? Thousandth, okay. That's 3 decimal places. All right, you need to put in the calculator. All right, so hit Control the division sign to get that up. All right, the log button is right here above the 10 to the x, so control that. Now the base, the base is 10, right? So you could put 10 in there, but notice that if I just put in 3.75, it automatically, when I put to the bottom, well, it will end up putting in base 10, I promise. Control log, and this is of what, 3.2. If you do not put anything in there, it will assume it's 3.2. Let's see, it puts the 10 in there. You could put the 10 in there, but you don't have to. It will automatically do that for you. All right, and it gives you the answer of 1.1. So, whoops. 1.136 rounded to 3 decimal places. That is the rounded answer. All right, so let's do 17. I'm going to keep the calculator up here since we're going to have to use that for things as well. Okay, so now we have a log equation. When you have a log equation, you have 2 things that can happen. You can either have logs on one side or logs on both sides. Anytime you have multiple logs on either side of the equation, all right, you got to condense them first. We only have one log. So if we have one log like this and it's only on one side, we rewrite it as an exponential. So it's 3 to the 7.24 equals x. Left, right, left. All right, it's the base. So this power equals that number. All right, so that is our exact answer right there. All right, that's the exact answer. To get round to the nearest thousandth, we would just come over to our calculator and we hit 3, caret button, 7.24, enter, and that answer is 2,846.81. There's our answer. All right. All right, 18 is another just log. All right, so you rewrite it as an exponential. It's only one log on one side. So it's the base, which is 10, to this thing over here, 3.4, equals, you go back to the left, 5x plus 2. All right, and now you solve this equation. Subtract 2, so it's 10 to the 3.4. Notice I'm not figuring out what 10 to 3.4 is yet. Whoops. So, hold on. Minus 2, get the 2 on the other side, equals 5x, and then divide by 5. That right there is the exact answer. 10 to 3.4 minus 2 divided by 5. To get the rounded answer, you come back over here, you put in the calculator, 10 to the 3.4 minus 2 all over 5, and that answer is 501.977. Right. All right, on to page 2. Oops. What happened to page? Let's see. Hold on one second. All right. Sorry for the little bit of confusion there. I was looking down, and on this paper, I didn't realize that they were numbered wrong. So we'll just keep going the way they were in the paper. So we'll do 28, even though that this should have been the third page. You guys probably already saw that. I just figured out now that the numbers were all wrong. Okay. So this absolute value one. So it's an exponential one though, right? So you have 9 and you have 27. The bases are not the same. See if you can make them the same. If you can't make them the same, then we have to add a log to both sides. We can make them the same, right? Can I make this 3 squared, right? 3 squared to the absolute value of x plus 2 equals 3 cubed, which means I only need to worry about the exponents, setting the exponents equal. So 2 times the absolute value of x plus 2 equals 3. So to do an absolute value type, you have to make 2 equations. Before you do that, you have to isolate the absolute value. So I divide by 2, and I get the absolute value of x plus 2 equals 3 halves. So 1, I leave exactly the same, leave everything in the absolute value, and this is the same. And then I do x plus 2 equals negative 3 halves. All right. The whole problem is the same, 1 positive, 1 negative. All right. So I subtract and I get negative 2 minus is negative 1 half. Negative 2 minus 3 halves is negative 7 halves. So I get negative 1 half and negative 7 halves. Obviously, that's the exact answer. You don't need to round that to a decimal answer. It's already good the way it is. All right, so now for this one, we got 3 and 7. We cannot make those the same. So just add a log to both sides. Now you could make it a log base 3 if you wanted to, but I'm just gonna let's make it a log. Just add a log to both sides. Use a base 10 log, it's okay. So we bring the exponent out front. So x log of 3 equals log of 7. Divide by log 3. And that is your answer. Log 7 over log 3. To get the exact answer of that, come over here. You get log of 7 over log of 3. Hit enter. And it is 1.771. There's your answer. All right. Now, here's the first case, that we have a log on both sides. All right, we have a log on both sides. However, we have other things that are going on here besides just the log. Now, if this 2 wasn't here, all right, if this 2 was not here, we had a log on both sides, we would just cross out the logs and set these equal to each other. But unfortunately, we don't have that case. All right, we have this 2. All right, so I can't just cross out the logs. All right, so let's get, if there's other things, let's get the log on the same side. So I'm going to rewrite this as log 3x equals, minus log base 3 of 2x minus 5 equals 2. Okay, so what I want to do is I want to condense the logs into one log. So it's going to be log base 3. It's subtraction, so it's going to be x divided by 2x minus 5 equals 2. Now I have one log. I rewrite it as an exponential. You take the base over to the right to that power equals x over 2x minus 5. All right, so that's 9. So I have 9. This is over 1, right? So I'm going to just cross multiply. So it's going to be 9 times that. So it says 18x minus 45 equals x. subtract, so I get negative 45 equals negative 19x, and divide by negative 19, which is going to make it positive. So x equals 45 19ths as my answer. All right. What do we got next? Okay. 31. All right. These are different. The exponential, bases 2/3 and 9/4, but they're almost the same, right? Isn't 9 3 squared and 4 2 squared? So can I rewrite it as 2/3? It's not squared because it's 9 over 4, but if I flipped it, I can make it a negative. So they're now the same. I can just set x minus 1 equals negative 2. And x equals negative 1. Done. That's all you have to do. So if you realize, you just got to realize how to make the bases the same. All right. 32. Here's the another exponential. Bases are 2 and 3. You can't make them the same. So you have to add a log to both sides. So we're going to do log of 2 to the 5x plus 1 equals log 3 to the 4x. All right, now this is where, when you have a variable in both, this is where it's going to be advantageous if we just do this. Let's make one of them let's make it, instead of being a log 10, let's do a log 2 or log base 3. I'm going to make it a log base 2 instead of a 10. All right? Because what happens when we move these things up front, 5x plus 1 log base 2 of 2 equals log, whoops, forgot to move it up front. Move the exponent out front, 4x of log base 2 of 3. Okay, because what is this right here? Log base 2 of 2, that's 1. So now I'm left with 5x plus 1 equals 4x times log base 2 of 3. All right. So I want to try to solve. Now I just need to try to solve. Now remember, this is all one thing. I want to try to solve for x. So when you have a situation where you have multiple x's here, you have two terms that have an x in it, we want to get all of them to one side. So let's subtract the 5x over. So 1 equals 4x log base 2 of 3 minus 5x. And how we can get it down to 1x? Always just factor it out. So 1 equals x parentheses 4 log base 2 of 3 minus 5. And then to solve for x, we are just going to divide by all of this, right? 4 log base 2 of 3 minus 5. Then do it to the other side. 4 log base 2 of 3 minus 5. So there is my answer. All right, 1 over 4 log base 2 of 3 minus 5. All right. All right, now 33. Got a lot. We have 1, 2, 3, 4 terms, logs. Logs are on both sides, but we want to condense the logs first. This is going to then become a very easy problem. Let's condense the logs first. It's plus, so this is multiplication. So I can rewrite this as log of this times that, which is x squared minus x, equals log of x this times that, which is, what is that, 16x minus 24. I have logs on both sides. There's nothing else on either side besides logs. These logs just cancel. Set this equal to each other. X squared minus x equals 16x minus 24. All right, now quadratic, let's factor this, set this equal to 0. So that's x squared minus 17x plus 24 equals 0. And that doesn't factor, which I Mr. Gillard is not very bright. So what happens when you try to rush through things. Okay. Hopefully you're like, as you're watching this, Mr. Gillard, how do you get 16x minus 24? This is a minus. What does a minus mean? It means it's division. All right. So that means it's 8x minus 12 divided by 2, which should be 4x minus 6, right? Because it's division. When you combine these, it should be 8x minus 12 over 2, which is then 4x minus 6. Now, I bet you this will factor. Let's see, 4x minus 6, x squared minus 5x plus 6, which is then x minus 3 and x minus 2. All right, which means 3 and 2 are possible answers. Make sure that when you plug in, you get all positives. Pot 3, yes. 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 2, yes. So both work. All right, 3 and 2 are both answers. All right. All right, now expand your condense completely using the laws of logs. All right, so obviously this is one where you're going to have to expand it. All right, real simple. All right, anything up top gets a positive, anything on bottom gets a negative, and the exponents go out front. All right, so you're going to have this, and this. You have 3 different logs. So 2 log base 3 of x plus the 5th root means 1/5. 1/5 log base 3 of x minus y minus, since it's on the bottom, 4 log base 3 of 2x plus 1. There's my answer. Here I have 1, 2, 3, 4 different things. So it's 2 natural log of x plus 3 natural log of y minus, because we're on the bottom now, 4 natural log of z minus square root is the same thing as 1/2. 1/2 natural log of q. All right. Now for condensing, we just do the opposite. These are all natural logs. So I'm going to put, and I see minuses, so it means it's going to be a fraction. So I'm going to put a big natural log. I'm going to put a fraction bar. And anything on the negative gets a bottom. Anything with the negative in front goes on the bottom. So the x goes on the bottom. It's cubed. All right. Positive goes on top. So the x plus y is to the 5th, because if it's up front, it's an exponent. Negative goes on the bottom. 1/2 means it's the square root of 2x plus 3. Positive goes on top. X plus 4 to the 3rd. Now you can put all this in parentheses if you want. If you didn't, not a big deal. All right. All right. For this one. All right. All right. So we have log 5th, and we have 10x squared minus 13x minus 3 over 2x squared minus x minus 3. All right, so this does factor. So you would have to factor that to 5x plus 1, and I think that's 2x minus 3. All right, this factors to 2x minus 3 and x plus 1. All right, the 2x minus 3's cancel, and you're left with log base 5 of 5x plus 1 over x plus 1. All right, so just add a little algebra in there, but this is just knowing that you have to write from there to there is just fine. Okay, so that's expanding and condensing. And then last thing in here on this page, changing from logarithmic to exponential form or vice versa. All right. Now, all right, so to change this, all right, this is, excuse me. All right, this is your base. It's the base of the exponent, but it's also the base of your log. So it's log, and then the base is whatever this is, of, then you go to the right side. So it's just b equals whatever the exponent is. right? This is your base, so we're just going to use natural log. The natural log of this, the right side, equals whatever the exponent is. Natural log of 3 equals x. And then for this one, we change to exponential. It's the base to that. Then we come back to the left. Left, right, left. B to the x equals z. All right. Now we're going out of order. So now the last page, we just have to solve equations here. All right, so exponential, get the exponential by itself first. Isolate it before we do the logs, all right? So add the 3 over, 11 equals 1/2 5 to the x, multiplied by 2, so I get 22 equals 5 to the x. Whoops, not 5x, 5 to the x. All right, so I cannot make 22 and 5 the same. All right, so add a log to both sides, log of 22 equals log of 5 to the x. Now, since there's only variable on one side, you can just put a log on both sides. You can make this log base 5 if you want. It doesn't make a difference. It's going to make it one step easier, but whatever is easier for you. So I'm going to move the x out in front. So this is really like x log of 5, and we divide. So it's x equals log of 22 equals log of 5. Then if I wanted to figure out the exact value of that, it's log, control log of 22 over log of 5, enter, 1.921. There's your answer for that one. All right, for 20, multiple logs on one side, you have to condense that. So this is going to be natural log, it's subtraction of 5x over 2x plus 3. All right, equals 0. Now, rewrite it into an exponential. What's my base? My base is e. So it's e to this power, which is 0, equals 5x over 2x plus 3. What's e to the 0? It is 1. 1 equals 5x over 2x plus 3, which means 2x plus 3 is equal to 5x, which means 3 is equal to 3x, which means x equals 1. All right, you plug that back in and make sure you get all positives. You do, you're good. All right, 21. All right, so here we have to isolate this first. All right, so I subtract 1, which is 13 equals 2/3 to the 3 times 3.8 to the 5x, multiply by 3/2, which gives me what? 39 over 2 equals 3.8. Sorry, my handwriting's getting really better now. To the 5x. All right, so now we can take the log of both sides. All right, so we got the log of 39 over 2, which I can rewrite as 19.5, equals, I'm just putting the exponent out in front to start, 5x of log of 3.8. So now I just divide by 5 log 3.8 to solve for x, right? That cancels. So the answer is log of 19.5 over 5 log of 13 point, oh, not 13, it's just 3. Sorry, 3.8. All right, and there's your answer. All right, to figure out what that is over here, you would do same thing we've been doing, log of 19.5 over 5 times the log of 3.8, giving us an answer of roughly 0.446 5. All right. All right, next one. Where is it? Here. All right, another exponential. All right, get it by itself. So I get 24 equals, so that's gone, equals this. I'm going to divide by 3. So I get 8 equals 5.1 to the 0.3x. All right, add a log to both sides. Log of 8 equals 3x log of 5.1. Scroll this down a little bit, more room. All right. Divide by 3 log 5.1. And my answer is log of 8 divided by 3 times the log of 5.1. All right. You would then go over here and do the same thing. Log of 8. Whoops. See, now you got to be careful. It's log 8 there. Make sure you put the 8 in the right spot. Divided by 3 times log of 5.1. Enter. And we get an answer of 0.425. All right. As I'm looking at this, that's a 0.3, isn't it? Sorry. So that's a 0.3 there. I should change that to 0.3. That's a 0.3, which means this answer is not right. You would have to, let me just do it again. Sorry. Log of 8 over, what's going on here? Over 0.3. Sorry, it's 0.3 log of 5.1. Enter. Sorry. So it's 4.254. All right, there's your answer. All right. So I missed the 0.3. So be careful when you write. Okay. So for 23, multiple logs on one side. Let's condense them first. It's plus, which means it's multiplication. Log base 2 of x. So I'm just going to, that's 3x squared minus 5x equals 1. So when you have log on one side like this, you rewrite as an exponential. All right. So it is going to be the base, this to that power 1 equals 3x squared minus 5x. So we now just solve this. 3x squared minus 5x, bring the 2 over, so it's minus 2 equals 0. All right, we try to factor that. 3x, x, and let's see, 2, make that a minus, that a 1. Let's see, does it work? Yep, negative 6x, perfect. So I get negative 1/3 or positive 2. Now, here's the problem. If I plug in negative 1/3 there, you get a negative after log, can't have it. So you don't even have to check the other one. It's no good. 2 there is good, 2, 6, 1, good. So the answer is 2. All right, 24. All right, very similar problem to 23. Condense first. So it's going to be log base 2. This is a division, so it's 3x over 5x plus 1 equals 3. So we write as exponential. 2 to the third equals 3x over 5x plus 1. This is 8. All right. All right, so this is 8 really, right? So we're going to cross multiply. So that'd be 40x plus 8 equals 3x. So that's 8 equals negative 37x. So then x equals 8 negative 8/37. However, if I plug that in there, it gives me negative. So that doesn't work. There's no other answer. So the answer is no solution. All right. So if you have two logs on one side like this, you condense them, rewrite it exponential, but make sure you check your work. All right. To see it, make sure you cannot have a negative number after a log. All right. Last three. All right. Same exact problems that we've been doing here. Same type. All right. Multiple logs like this, condense them. So log base 3. This is a plus, means we're going to multiply these things together. So 10x squared minus x equals 1. To rewrite into an exponential, it's this to that power equals that. So 3 to the first equals 10x squared minus x. So set this equal to 0. 10x squared minus x minus 3 equals 0. Let's see, I think it's 5x and 2x. Let's see, 3 and 1. And we need that to be a negative. So that's a negative. That is a positive. All right. So your answers are positive 3/5 and negative 1/2. Once again, we go to plug in, and this does not work because you get a negative after here. 3/5 works there. 3/5, that's 6. That's good. So the answer is 3/5. Okay. Here, same thing. Two natural logs. So it's a natural log of 5x. Whoops. See, don't. It's a minus, which means we divide. So it's x over 5x minus 3 equals 2. So we write this as e squared, because that's the exponent, equals x over 5x minus 3. This is really over 1, so I cross multiply. So that's 5x e squared minus 3e squared equals x. All right, so to solve for x, we need to get all the x's on one side. So 5x e squared minus x equals positive 3e squared. Take out an x, which would be 5e squared minus 1 equals e squared. And we're going to divide by all of that. So e squared divided by 5e squared minus 1. And there's your answer. And last one. All right. We have 4 and 1/8. Well, we can rewrite this in terms of 2. 2 squared, let's say 2 squared to 3x. And this is 2 cubed, but we just make it negative, right? 2 to the negative third, right? That's 1/8. 2x plus 1. So it's, forget about the basis. We just have the exponents. 2 times 3x is 6x. Set them equal to each other. And then negative 6x minus 3. Add, I get 12x equals negative 3. I get x, divide that by 12, right? Yeah. And I get negative 1/4, right? Negative 1/4. All right, so that's the last problem on here. All right. So hopefully after seeing these, you guys, if you had any questions, you guys are cleared up. If you still have some concerns, just let me know. All right. Hope you guys are doing well. And remember, quiz will be tomorrow. All right. Bye.